Hello class, welcome to week 5 of Programming Logic with Python. So I did release another video about for this week, but there were some audio issues. My voice was not in there even though the music was there. Usually I have like very light music in the background while I'm speaking, but for some reason the music overtook my voice or my voice just never registered. Not really sure what was wrong with that, but I had to throw that entire video away, so I'm going to make another video. So I'm going to try to make sure I hit all the topics I originally hit in the first video. So let's kind of get started. So week 5, we're going to go over list and tuples. So let's start with the list. A list is basically like a collection of they use the word elements, but you could kind of use or think of values. So like when we assign a value to a variable, um, the value is whatever is being stored inside of the variable. So in the case of a list and an element, the element is being stored inside of the list, but the list itself is actually a whole collection of items, and all of that is being stored typically inside of a variable as well. So yeah, a list is still assigned to a variable. It's just like holding multiple values. So as we see in the example over here, we have list1, which is our variable. We're equating it a value of a list, and my list actually has 3 items. So the first item is chocolate milk, the second item is ice cream, the third item cookies. So those are my 3 items. Those individual items, because they are individual items because they're separated with a comma, are individual strings, and we know they're strings because they're surrounded in quotation marks. So just keep that in mind. So like everything we're learning in previous weeks, we're just building on top of it. I do know that we briefly covered lists in a previous week, but I just felt like I should give you guys a refresher on how to create a list, how to access elements inside of your list, and so forth. And we're going to go even beyond that into like specific methods that we use with the list. So right now, that's the most basic way you create a list. You typically assign it to a variable. So a variable name equal square brackets. So square brackets are actually really important to use because the square brackets will tell you, well, we'll tell Python that whatever I'm putting inside of here is a list. It's a collection of elements or values. So just make sure you include the square brackets. So as far as these commas go, just make sure between each element, so like say you have 2 elements, you put 1 comma in between those 2 elements just to separate them, or else then Python's going to assume that it's just one big element, and it might error out. So like if you have 2 strings right next to each other without the comma, um, yeah, so it might not. So just keep that in mind. The commas are important. The square brackets are important. And so if I wanted to print out my list, I would just do this, the regular print, and then whatever variable storing my list. So in this case, the variable that's storing my list is list1. So if I were to run this code, I'm just gonna make sure you guys actually see this. Okay, so yeah, here I have all 3 of my elements being printed out, but notice that Python is printing them out with the square brackets surrounding them. So Python is actually doing that just to kind of like confirm to the user, because this is user output basically, output that the user will see. So it's just telling the user, yeah, these values exist inside of the variable of list1, but they actually pertain to a list. So I'm going to include the square brackets just to tell you that these are a collection of items. So that's why Python does that. So there are other ways we can collect items inside of Python. So a list is the first one, tuples is a second, and then we get into dictionaries and so forth. But dictionaries and so forth come later on. This week we're just going to focus on lists and tuples. There are differences in between all of them. So yeah, each way of collecting items does have their own unique advantages and disadvantages. So we will touch on that briefly as well as we go through this. But a list is very flexible. So a list, let me go back to the original code. So if you notice, a list has, well, my list has 3 items: chocolate milk, ice cream, and cookies. And when I printed it out, it printed them out, each of my elements in my list, in the same order that I put them in. So Python, when it comes to list, it's a list is an ordered collection of items. And what I mean by ordered collection is whatever index position you place your element, that's the index position that it will stay at, unless you obviously tell Python, hey, I want to replace it, I want to remove it, or so forth. But if you don't tell Python any of that, and you just leave it as the original list, as I have right here, of chocolate milk, ice cream, and cookies, it will stay in that order. So just know that in Python, lists behave that way. Another characteristic of a list is that, as I just mentioned, we could remove and we can change specific elements inside of our list to our liking. So right now I have three elements, and those three elements are chocolate milk, ice cream, and cookies. But what if I wanted to add a fourth element? Or what if I just wanted to remove or the second element of ice cream and replace it with maybe like I don't know, cake? I could do that. And the way you do that is, well, actually you have two ways. You could use indexes, or you could use methods. Both work. But we're going to get to that. But just know that you can change elements inside of a list. It doesn't quite work that way when we get into tuples, but I'll get to that when we get to that. One last unique characteristic of a list is that a list can actually take in multiple data types. So like I can place a string, I can place an integer, and so forth, all inside of my list, and the list will accept all of them. So I want to say there was one more. So with data types. I might be forgetting one more, or maybe not. But those are the three core ones. So you accept all data types. It's mutable. Mutable meaning you can change stuff inside of it, and it's ordered. I feel like I'm forgetting something. It's okay. If I remember, I'll let you guys know. So let's move on to the next part. So the next part is the insert method. So this is the first method that we're going to be learning in this video. There are a variety of methods in Python when it comes to lists. So let me just change this, because I did change the variable name of my list, or the variable name that stores my list. Okay, so the way you kind of implement methods is very straightforward across any method that you use, pretty much, when it comes to a list. So it's the variable name that stores the list. So in this case, it's a list1, period, and then whatever the name of the method is. So in this case, my method, the first method we're going to be working with is the insert method. So I'm just going to do period insert, and then open and close parentheses is always common with most methods. So don't forget that. So the syntax is pretty straightforward. It's list1 period insert open parenthesis, and then in this case I have two arguments inside of it. The first argument is actually the index position that I want to manipulate in this case, because I want to insert something. So I have to tell Python where to insert whatever value that I'm telling it to insert. So I'm telling it in this case to insert whatever value, which I'm gonna get to, at index position 0. So as you guys know, index position 0 is if we're talking about positive indexes, it's the very first element in that collection. So if it was a list, it would be chocolate milk. If it was a string, it'd be the first letter of that string, and so forth. So it's just basically the first entry in whatever we are dealing with. In this case, it's a list. So I'm telling it to insert at index position 0, but what is it going to insert? Well, you do a comma to separate the position you're manipulating and whatever value you're going to add to it. So on the right-hand side is the actual value that I want to insert, and that value is a string called pineapple. So I'm telling it at index position 0, insert pineapple. So remember, I'm manipulating this list up here of list 1. So what do you guys think is going to happen? Is it going to be, if I print out this list, I would have to actually get rid of this, just so that it doesn't print out this list before I do that insert. I want to print it out after the fact, just so that it's not too jumbled, my output. So what do you guys think is going to happen here? Is it going to be pineapple, chocolate milk, ice cream, cookies, or is it going to be pineapple, ice cream, cookies? Will it replace it, or will it just push it over? Um, so you guys can guess. Obviously, you guys can pause the video. I'm going to run the code just to kind of show you guys. My mouse works. Okay, yeah. So it's actually going to push it over because when you insert, it's kind of doing exactly what it says it's doing. It's inserting. It's not like replacing. It's not appending. It's just like it's not deleting. It's just inserting. It's inserting at that position. Everything else gets pushed over one. So if I'm saying at position 0, index position 0, then chocolate milk, which originally existed at index position 0, now gets moved over to index position 1. So pretty straightforward, nothing too complicated there. So that's the first method I wanted to kind of go over with you guys because you might see that in your homework assignments. So I'm going to delete this. We're going to move on to the second method. So the second method is the append method. So this method is actually, I kind of wrote a brief description of what it does. It does what you kind of think it does. It adds to a collection. But it's unique in where it adds it to. It adds it to the very end. So if I have a list, so like we have a new list right here of this list. That's the variable name and I'm assigning it a value of 3 items in my list. And those 3 items are apple, banana, and cherry. So those 3 items, yeah, they exist there, great. But I kind of want to add another element to my list. Now, I could just do the insert and just say, hey, insert at like index position 3. Because this would be 0, 1, 2, and put it at 3. I could do that. I could also just save the headache because, like, say this. Well, this list is pretty easy because it's only 3 elements. But say you had a list of like 90 elements. Do you really, or like 86? Do you really want to like do the math and be like, okay, I have 86 elements. Then if the first element starts at index position 0, then where I want to insert is whatever. That just hurts my brain because like I told you guys many times, I'm not very good at math. So instead of doing that, this just saves you the headache of just adding it to the very end, if you want to add it to the end. But if you want to add it to the end, you use the append method. If not, then you use a different method. So the append method is, like I said, very straightforward. So let's look at this list. So we have this list, same syntax. So it's this list, period, because this list is my variable that holds the list, period, append. So the syntax doesn't really change. It's the word that's changing here, whatever method we're using. And then we still have the open close parenthesis. And in this case, we only have one argument that append is taking. So that one argument is whatever we want to add to the end. So in this case, I'm adding a string called orange. It doesn't have to be a string because if you guys remember, a list can take multiple types of data types. So I could add a integer, I can add a boolean, I can add a float. It really doesn't matter. It will take all of that. And then if I were to print this out, we're just going to see a list of apple, banana, cherry, orange, as we do. Great. So yeah, append is very straightforward. Most of these methods are straightforward. So that's kind of why I'm going through them a little bit quick. This week is really just, when it comes to lists and even tuples, there's really only, it's not that there's only one way of writing a list, but you can't really go wrong when you write a list. The syntax is very easy, it's very straightforward. It's just changing whatever variable storing the list and then whatever elements you want to include in the list. And then where the complexity comes is remembering all the methods. So there's tons of methods even beyond what I'm going to cover in this video. There's even more methods, but these were the ones I felt were the most important for you guys to at least complete your homework assignments. So like I said, there's a lot of methods. You don't have to memorize everything at once. That's what Google's for. Because even when you do become really good at programming, a lot of times you will reference Google and like Stack Overflow for specific lines of code that you might not remember off the top of your head. So that's okay. That's perfectly okay. If you guys can't remember all of these right now, that's fine. As long as you're good at Googling what the extend method is, and then implementing it and knowing like, oh, okay, well, variable comes first, period, extend, open parenthesis, and then whatever argument I'm putting inside of it. As long as you know that pattern, you'll be fine. And with time, you will kind of like, through using these methods many times, you're going to become very familiar and you won't have to Google all of them, but some you might have to, especially when like they accept multiple, like some methods accept multiple arguments, they could accept just one argument. That's really where you can trip up on. But as far as like writing the syntax of the method, it's relatively straightforward. So yeah, sorry about that little ramble. I just thought it was pretty important because we're going to go over a lot of methods. I don't want you guys to be intimidated by them. So the second method is the extend method. So the extend method, a lot of these methods do what they say they're going to do. So what do you guys think the extend method is going to do? So like say we have a list that's already created and we want to extend that list with a series of items. And that series of items could be another list. It could be like list two. It can be a tuple. It could be a string, like an individual string, so forth. We're just extending from an original list. So I'm going to keep this top list of apple, banana, cherry intact. I'm just going to remove this print statement. So I'm also going to leave this append because I do want orange to be added to this original list. So I have, just like knowing that in the back of my head, this list right here of this list actually has 4 elements, even though it only has 3 up here. So if I'm going to extend off those original 4 elements and I want to say add this list right here, that's stored inside of the variable of tropical. So this list has 3 elements. It has mango, pineapple, papaya. So I want to add those 3 to my original list. So in order to do that, once again, we start off with a variable that stores a list that we want to manipulate. So because I want to add to the list of this list, that means I'm manipulating this list. So that's why I'm including this list first, period, because I want to manipulate this list using a method. So period, extend, and then inside of the parentheses, that's where my argument's going, and that argument is actually not it could be a string, it could be a tuple, like a tuple that's stored inside of a variable. But in this case, it's a list that's stored inside of the variable of tropical, which is this list right here. So when I print this out, it should actually print out a list of 7 items, starting with apple, ending with papaya, and we can double check just by running this code. So yeah, so 1, 2, 3, 4, 5, 6, 7. Perfect. So I'm going to close that. So great. So now let's kind of move on to the next section, which is the pop method. So the pop method, okay, so this is probably the first method that actually doesn't explicitly say what it's going to do, because you could be like, oh, is it going to pop something? Well, actually, in that case, maybe it does. Because like if you think of like a balloon and you pop a balloon, it gets rid of it. The balloon is gone. So in that case, I guess if you are making that connection, it does do what it says it's going to do. But basically, it just deletes a element in a list, and there's 2 ways of using it. So the first way is if you don't include an argument inside of its parentheses. So we could kind of look at an example of that. So we have a list, a brand new list up here of CS underscore topics. And inside of that variable, I have 1, 2, 3, 4, 5. I have 5 elements inside of that variable. So that's stored inside of a list. So the next line of code is removed underscore element. So that's a brand new variable that I'm creating. I'm assigning that variable the list or the variable that stores my list, which is CS underscore topics. And now I'm implementing that method. So I'm trying to manipulate that list. So it's CS underscore topics period pop. And so when I do period pop, open close parenthesis with no arguments inside of it, what that's really doing is it's just removing the last element of my list from my list. So very straightforward. And then you might be asking, why am I doing CS underscore topics period pop, open close parenthesis inside of a variable? Well, that's just so that I can know what element I just removed from the list. So when I print out CS top or underscore topics, this is going to print out the new list. The new list, which is going to store Python, data structures, balloon making algorithms, and that's it. It's not going to store Clowns 101 because remember, I removed it up here. Now, for the second print statement, when I print out removed underscore element, that's actually just going to print out the element that I removed, which in this case is clowns 101. Hold on. Okay, which is Clowns 101. And the reason you might do that is because, like, say your boss says, hey, can you log into this computer and just, like, remove the final entry of our employee list? Because the latest employee, he worked here for a day and then he just decided it wasn't for him and he left. So can you please remove him from the employee list? Thanks. So you go on to the computer and you remove him from the employee list using Visual Studio, great. And when you remove him, you just want to double check that you removed the correct person and not some other new employee who may have started after him. So that's maybe like one reason why you would use that, just to double check what you did, because it removes the very last entry of your list. So like say if someone else comes after the fact, you're removing them when you're supposed to remove the second to last person. So it's just like a way of double checking your work. So it's pretty useful. Um, the second way of using the pop method is introducing a argument inside of the parentheses. So once again we have cs underscore topics period pop, but we're not placing this inside of a variable. We're just straight up saying remove the final, well, not the final, remove something from the list of cs underscore topics. And I say not the last because I did include an argument there, and that argument is actually the index position of what I want to remove. So if I wrote 2 in there, that means I'm saying remove index position 2, whatever element is there, remove it from my list. So if I were to print this out, so let me remove these two. So let's print this out and see what it gives us. Okay. That's because I never commented out any of this. Okay, so now it should work. So yeah, I have Python data structures algorithms, but notice that Clown 101 is not there, and neither is 0, 1, 2, neither is balloon making. So yeah, it's Python data structures and algorithms. So Clown 101 got removed up here, and then balloon making got removed here. So that's why we only had 3 elements in the list. So hopefully that makes sense. There's 2 ways of using it, and it's great for double checking your work. So the pop method has a variety of uses. So that's it for pop. So let's move on to the count method. So the count method actually does, well, I'm just going to stop saying that each of them do what they say they're going to do, because I think it can already be assumed that that's what's happening here. So the count method counts how many times a specific element appears inside of your list. So this is really good when you have like multiples of a certain entry inside of your list. So say you have like your boss comes up to you and he's like, okay, well, I need to take inventory of, say, like the number of computers that we have in our office. I know we have like a lot of Macs in our office, but I just want to double check how many Macs we have. So in order to do that, you could use the count method to count how many, say, like you could just do Macs right here. Instead of I, you could do Macs. Do like MacBook. Say you guys have like you guys use MacBooks in your company. Just type in MacBook, and then it'll search the list and tell you how many times it finds the word MacBook inside of your list. And obviously, you could be more specific in this. You could be like MacBook Air or so forth. So in this case, in my example, I have the word of Mississippi, and I'm just saying whenever you see the string I inside of this list that contains all of these letters, which total the word Mississippi, just count it. So like it should print out 4 because there are 4 I's in Mississippi. And I assigned all of this inside of a variable. It's not needed. I could have just done, so let me write this out. I could have just done letters period count. I could have just done like then I have to do another set of parentheses because remember, this set of parentheses right here belongs to the count method, and then there's the set of parentheses for the print function. So it's just make sure you do the parentheses correctly. So this would be valid code. I don't have to do this line right here, but I am doing that line just to make my life and my code a little bit more clear. Life easier, code clearer. Because instead of writing all of that inside of my print statement, which could become very messy. I could just write num underscore I, which is the name of my variable that's storing that manipulation of my list using the count method, and it does the same thing, just like how we saw the pop method up in our previous example. So it's just a cleaner way of writing your code, so that's not all messy. Right now, we're not including a lot of stuff in our code, but as you progress in difficulty, I know Tunxus only offers the intro level of Python, where we're just learning the basics. But if you were to take a more advanced class in Python or in another language like Java or C++, um, the code becomes a lot more jumbled, and using shortcuts like this to clean up your code it just makes your life a lot easier, honestly. So that's why I'm doing that. I'm just trying to teach you guys good habits. So that's it for the count method. Let's move on to the sort method. So this method is actually the last method that I wanted to touch on in this video. So this sort method does what it says it's going to do. It's going to sort your items. So like I said, Python is a organized or structured, yeah, did I say organized? Yeah, I think it was. I think that was the word I used. Ordered, no, ordered, not organized. It's an ordered way of. It's an ordered collection of data. So if I were to write my elements in a list, such as I did right here, it would stay like that until I tell Python, hey, I actually want you to rearrange that from A to Z. So if I wanted to do that, I would just use the sort method, and the sort method could take an argument. It doesn't have to take an argument. It's kind of like pop in that aspect. So we're going to look at both examples. So the first example, my list is stored inside of the variable of names. So just keep that in mind. So I have names period sort. So that syntax doesn't change. It never really does with methods. And then I have open close parentheses. So because I'm not including an argument inside of there, Python just reads, okay, well, he just wants me to sort from A to Z. So that's what I'm going to do. So I'm just going to check the first letter of every element inside of his list, or if it's like a number, I'll just sort it that way. And I'll just kind of put it in order as such, from ascending to descending, or from ascending order. Yeah. So if I were to print this out, so let's print this out. Yeah. Okay. So it changes the order, and that becomes the new permanent order. As long as I don't remove that line of code from my program, that's the new permanent order. Because remember, Python reads from top bottom, so everything I put after the fact, names now is structured in such a way. So like say if I were to like add something or add an element to my list of names, it would, well actually, say I added an element to the very end using the append method, and say it started with the letter A, that letter would still go to the end because it sorts up here. It wouldn't sort after the fact. So if you wanted to sort it again, you would have to use the sort method again. So do keep that in mind. So yeah, sorry, just thinking of that. So there's another way of using the sort method. So the second way of using the sort method is using a argument inside of it. So we have, once again, the variable that stores my list of names, period, sort, open parenthesis, and now we're saying reverse. So reverse here is not necessarily a variable. It's actually like a special keyword. So it's just saying reverse, and I'm saying reverse equals true. So the special keyword of reverse, which changes whatever order something's in, and then I'm saying, yeah, that's true. So like, do that basically. And that true is actually Boolean true, because remember, Boolean starts with an uppercase T for true or F for false, and everything else is lowercase. And that's why it's also a different color. So yeah, basically here I'm just saying reverse equals true, so just reverse the sort method. So instead of doing from A to Z, do Z to A. So if I were to print this out, let me get rid of this print statement. Yes. Oh, I have to comment out the rest of that. Now we can print it out. Yeah, so now it's starting from Xander, Willow, Giles, so forth. So now it's going in the opposite order. So that's pretty much it for the sort method. Pretty straightforward. So one more thing I actually do want to mention about the sort method. The sort method does affect the original list. So this original list of names will get permanently changed. And you basically, it's like when you make a copy, like you have a drawing. So yeah, say you drew something on a piece of paper and you want to make edits to it. So you start drawing on top of it, or you start like erasing stuff. Like say you wrote it in pencil or you drew it in pencil. Um, and you start erasing stuff, you erase certain lines and you make new lines. That's essentially what the sort method is doing. It's manipulating the original copy. Now, what happens if you want to just like sort something, but you don't want to necessarily mess up the original because you don't have clearance from your boss to do so? In that case, you would use the sorted function, which is actually very similar to the sort method, but it does have some distinctions, and I do need that names list again, so I probably don't want to delete that. So I'm just going to keep that names list. Okay. So let's get rid of everything else. Okay. So the sorted function is similar to the sort method. They're not the same thing. So like I said, the sort method affects the original list itself. The sorted method or the sorted function actually makes a copy of the original list and then sorts that copy. So you're never really affecting the original list. And another thing is instead of the usual syntax of variable period sort or whatever method name it's going to be, and then open parenthesis, when you start using the sorted function, that actually the sorted keyword goes before the variable. So it goes, in this case right here, it goes sorted, and then open parenthesis names, which is my variable that stores my list, and then close parenthesis. So do keep that in mind. It's a little bit of a reverse from what I was just repetitively telling you guys with all these different methods. So just make sure you guys write the sorted function the correct way. So I'm storing the sorted function that's manipulating my list. It's not actually manipulating my list, it's creating a copy. But all that is happening inside of a new variable called sorted names. And I'm doing that just so that once again, when I print it out, it's just easier, it looks cleaner. So I'm just printing out sorted names, but you know what it's doing. It's taking the original list of names, making a copy of it, uh, sorting it from A to Z, and then printing that out to the user. So that's really all it's doing. So if I were to print out, so you're going to see two examples. So you're going to see sorted names, which has the copy of the original list that was in names, and then I'm also going to print out names. So you should see two different lists, but we're going to double check. So yeah, so the original list is the sorted names list, which was the copy. The second list was the original list. So that's why it started with Xander and so forth, because remember, I deleted the other lines that were up here under the sort method. So yeah, that's pretty much it for the sorted function. Pretty straightforward as well. So the range function, I did include that here because we do use the range function for our lists, for creating lists. So I'm just going to briefly touch on it because we have covered it and you guys have been using it throughout your homework assignments, I believe. So if you wanted to just get a range of something, so like in this case, I'm saying range 10, right? So range 10 is really just going to print out open parenthesis 0, comma 10, close parenthesis. It's just going to give me kind of like a range. But what if I wanted a series of numbers from 0 to 10? Well, if I wanted to do that, I would put it inside of a list. And to do that, you just preface your whatever list or whatever range you want, and you preface it with the keyword of list. So right here, remember, I did the range 10, and I stored that inside of the variable of my range. And then right here, I put list, open parenthesis, my range, close parenthesis, close parenthesis. So the first parenthesis belongs to list, the second parenthesis belongs to the print statement there. So if I print this out, you should see two different ways of using the range function, and obviously there's even more ways. So this is just giving me the range. So if I just give it one number, it's just going to start from 0. It's going to be 0 through 10. If I gave it two numbers, so like 1 or 1 through 10, so it's going to print out it's going to give me a range of 1 through 10. And And if I used it, if I did it with the list keyword, it would give me a series of numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there's a third way of doing it using the range function. So you could give it a beginning, you could give it an end, and then you can give it however many numbers you want it to skip over. So if I wanted this list to skip over every 2 numbers, let's start it at 0. Then I could just do 2, and that'll be the number of times that it just kind of skips over that specific range. So there's a variety of ways you can use the range function. So let me get back to what it originally was, and then I'll print this out just so you guys can kind of see it. The first one, it's just like it tells me range 0 through 10. The second one, when you preface it with the keyword of list, it actually gives you a list of all the numbers between that range. So that second way of writing it is probably more useful for when you're creating a list, when you're using the range function to create lists. So yeah. But you guys have done that before, so I didn't want to like spend too much time on it. So the third thing, or not the third thing, the next thing I want to go over is the length function. So the length function you guys have used before quite a bit as well. So I have this list of my list. I'm actually going to comment out the rest of this. How much is left? Okay. So I'm going to comment out the rest of this. So I have a list of 5 items in my list. So I'm saying print len open parentheses. So if you notice, most of these functions actually go the opposite way. So whereas a method goes variable period, whatever the method name is, when we're using functions, it typically goes, well, Python built-in functions, so not user-defined functions like we did last week. These are built-in functions. So when you're using a built-in function in Python, it usually goes before the actual variable that we're manipulating. So it goes the function name, so in this case it's len, and then we do the open close parenthesis. So yeah, just do keep that in mind. And then we're just length or len is actually just going to print out how many items are inside of that list or how many letters are inside of a word, like a string, and so forth. So it just returns the length of an object, and in Python, everything is an object, but we will touch on that, or the concept of everything being an object in a future week, where we go over object-oriented programming. But just know that in Python, everything is treated as an object, whether it's a string, whether it's a list or a tuple or so forth. So yeah, that's a length function. Um, so list slicing. List slicing. You guys have done slicing before, and this is the same thing. So I'm not really going to get too into this. Basically, we have a list called letters. It has a bunch of elements inside of it. And then I want to slice this list, which slicing just means I only want specific elements from this list to pertain to my new list. And I'm placing this new list inside of the variable of sliced list. So in order to slice, it's just whatever you're slicing, whether it's a string, in this case it's a list, which is stored inside the variable of letters. So I'm doing letters. And then after that, I do the square brackets. So the square brackets here will either refer to a list or it refers to slicing or index, or not a list. If you put square brackets after a variable, it typically refers to either slicing or index position. But in this case, I know it's not index position because it has the colon inside of it. So that colon's kind of like the giveaway as to like what it is, whether it's slicing or index position. So because the colon's there, I know we're slicing this this variable which stores this list. So we're starting the slice at index position 1, and we're ending it at index position 6. So the slice, if we look at our list up here, A actually pertains to index position 0, so that's not going to be included in my slice, but B will, because that's index position 1. And I'm telling it, Python to start my slice at index position 1, but for it to end at 6. So C is index position 2, D is 3, E is 4, F is 5, and G is 6. So will G be included in my slice? Well, no, because remember, when we tell it to end at a specific index, it actually doesn't print out that ending point. It prints out the one before that. So it's kind of stops at the index before what we're telling it to end at. So it's actually going to be from B to F. So if I am going to print, if I do print this out, it should be B, C, D, E, F, which it is. So great. So yeah, that's basic slicing. The slicing syntax and the way we do so doesn't change with lists. You don't have to specify the beginning point. You don't have to specify the end point. It can all the slicing stuff that I taught you carries over, so you don't have to worry about that. It's just I wanted to include this just to tell you that we could use slicing with lists. So that's pretty much it for that. So now we're done with lists. Pretty much you guys know everything about a list. Obviously, I didn't go over all the methods, but you guys will learn that as you need them, whether it's in this class, whether it's in a future class, or at your work. So now let's move on to tuples. So tuples are another way of collecting elements inside of a collection of data. Um, the difference is with a tuple, whereas a list is ordered, mutable, and what was the third one? Like including multiple data types, I think. I still can't remember that. I'm missing something. I don't exactly remember though. It's on the coding packet though. I'm pretty sure I included it on the coding packet, so you guys can always reference that. So the place where tuples differ, well, there's a couple places, but specifically, tuples do not allow you to manipulate, like change elements once they're placed inside of the tuple. So yeah, that's pretty much the biggest change. The other change is instead of using square brackets, we do use the rounded parentheses. So that's the other big change there. So let's look at ways of writing a tuple. It's very straightforward, just like a list. It's pretty much the same as a list. It's just those parentheses and one other thing that I will tell you about. So let's look at the example. So the first example is I have my tuple called my tuple, and then I'm equating it empty, open and close parentheses with nothing inside of it. So when I'm writing that, I'm basically just saying create this tuple, but it's empty. So I'll just put stuff in it later. So this is perfectly valid. I said you cannot remove things and you cannot change existing elements, but you could add elements. So that's perfectly fine. So in that case, creating an empty tuple is perfectly okay. And similarly, you could also create an empty list. I don't know if I mentioned that, but you could also do that. So the second example, I created, once again, well, actually, I should probably change this variable name just so that they're different. I can change this up here, and then I'll probably do like print my tuple2, and then I can print this out too. Print my tuple. Okay. So the second example is my tuple1. I'm equating it a tuple which has three elements. But there's something different here. So I do have the open and close parentheses, and I have the three elements inside of it. But for some reason, despite having three elements, I have three commas as well. So I have two commas in between those three elements, but then I have a trailing comma after the three. And the reason I have the trailing comma after the three is because it's needed. Because if you don't have that trailing comma, then Python has difficulty distinguishing a tuple from simply just assigning multiple values into a variable. So like if I were not to include this trailing comma, Python might think, oh, he's just assigning three integers to the variable of my tuple. Even though I have these parentheses, Python doesn't quite make sense of it. It requires that comma. So just make sure you guys do keep that in mind. Even if you're not going to add another element to this tuple, just so that Python knows that it's an actual tuple, do include that trailing comma. So another thing, this third tuple of my tuple2, this third tuple has three elements, and those three elements are of different data types. So that's perfectly okay as well. And once again, I have that trailing comma at the very end. And if I were to print all these out, so you guys can see what it looks like. So these three outputs. The first one is a empty tuple, and I know it's an empty tuple because Python is printing out those parentheses. So that's kind of the key giveaway, pretty much. that Python's basically telling us that this is a collection of items, but the collection of items is a tuple. So the second one, same thing. One thing you might notice is that when Python does print out these tuples, all of them, they're not including that trailing comma that I originally included in my code. And the reason is because that comma doesn't necessarily mean that there's it's separation of two elements. It's really just there for Python. It's not there for the user to see. So that's why Python doesn't include it in the output. So that's pretty much it. Tuples are relatively straightforward. A couple more things that you do have to remember when you write them, but not too much of a difference. So that's pretty much it for that. So let's move on to accessing tuple elements. So for accessing tuple elements, I have this new tuple right here. It has a bunch of letters inside of it that were all strings. And then I basically just want to print out specific letters of my tuple or specific elements inside of my tuple. And one way of doing it is by using indexes. So you guys have done this before when we've tried to get specific letters out of a string or yeah, I don't know if we used it in other cases, maybe with like loops. But regardless, in this case, if I wanted to get the first element of my tuple to be printed out, I would just do my tuple and then the square bracket, because the square bracket is for the index position. It's not necessarily it doesn't matter if I'm manipulating it or if I'm trying to, if I'm working with a tuple, the square brackets remain because in this case, this syntax right here, I'm trying to say index position of this tuple. So like I'm saying for this tuple of my tuple at index position 0, print it out. So whatever's there, just print it out for me. And so in this case, it's going to print out P. And for my tuple index position 5, it should print out T. So I wrote it right here, but if you guys don't believe me, I'll just run the code. So yeah, PT. So yeah, at its basic core, that's how you can like access elements inside of a tuple. Very simple. So I do have examples of slicing, and I'm not actually going to go over all of these because you guys already know how to slice. So this second example is using negative indexes. This third example is just using giving it a starting point and then just telling it to finish at the very end of the collection of items that we're going through. So we don't have to go over those two. I will just go over the first one. So the first one, we're working with a brand new tuple and it's being stored inside of my tuple. So I'm telling it for my tuple, start at index position 1 and then slice up until index position 4. So what do you guys think is going to be printed out here? Well, it's actually going to be ROG, so 0, 1, 2, 3, yeah, ROG. Because remember, index position 4, which is the second R, this R right here, will not get printed out because remember, even though I tell it to end at 4, it never prints out where it's ending at. It prints out 1 before that. So it's just gonna print out index position 1, which is R, index position 2, which is O, and then index position 3, which is G. And that's pretty much it. So the reason I have that here is because I just want you guys to know that you could slice with tuples as well. So you could slice with strings, you can slice with lists, you can slice with tuples, slicing with everything basically. So that's why it's really important to understand index positions, understand how to slice properly. It doesn't really matter if you prefer positive or negative slice or index slicing. Whatever you feel more comfortable with, whatever makes your life easier, as long as you know how to do one way, you're usually good. So that's it for that. Let's move on to concatenation. So I did learn how to say this word. I was practicing because it's a pretty, it's important to know it. I just always thought of it as the joining of two items, but yeah. So concatenation. So we have two tuples here. We have the first tuple. Whoops, I actually forgot my trailing comma. Okay. So my first tuple is it has 3 elements inside of it, 1, 2, 3, and then the trailing comma. And then my second tuple has 4, 5, 6, and then the trailing comma. So those are 2 valid tuples. Great. So I want to join them. I want to concatenate them. So in order to do that, use the plus operator. So if you remember from a previous week, we did learn about concatenation. and using the plus operator to join two strings. So in this case, originally then I told you you could only concatenate strings. And as you guys saw when you guys were going through the homeworks, when you guys tried to concatenate a string and a variable, you were running into issues there where Cengage or even Visual Studio wasn't liking it. I think it was mostly Cengage. So you guys were kind of prefacing it with like your integer with str and then open parenthesis and then your integer inside of it. But in this case, you don't have to do any of that. So even though these two tuples store integer data types or integer data values or elements, it doesn't matter. I can concatenate two tuples, perfectly valid. So I'm using the plus operator. So I have a new variable called combined tuple. I'm equating it tuple 1 plus tuple 2. So if I were to print this out, it's just going to print out 1, 2, 3, 4, 5, 6. And if I were to run this, that's exactly what you guys should see. Perfect. Okay. So that's pretty much it, concatenation. So very last topic. So what time are we at? We're at 50 minutes. Great. So I'm actually going to beat the time of that first video that I uploaded, maybe by like a couple minutes. So that's good. Okay. So the very last topic, I told you guys you cannot delete elements from a tuple. You cannot remove elements. You cannot change specific elements. Once it's there for life. You would think. There is one workaround though. So while you cannot mess with existing elements inside of a tuple, you could just say, I don't want this tuple to exist anymore. I'm just going to get rid of it completely. So in that way, you could manipulate the tuple by erasing the tuple completely. You're basically Thanosing the tuple. So the way you do that is you use the keyword of del for delete, so that you can delete the tuple. Now the del keyword, actually, I do believe it exists for using it with the list, but yeah, I do think you could use it with a list, but it really serves more of a purpose with tuples. Because remember, we cannot use pop with a tuple, because you cannot just like remove one element from a list. You can only delete the entire tuple. So that's why the delete keyword just becomes more useful with tuples. So in this example, I have a tuple, has a bunch of different elements inside of it, and I'm just saying delete my tuple. So now if I were to say like print my tuple, it's actually not gonna, you guys aren't gonna see anything. You're probably just gonna see a black screen, yep. But on my screen, so let me see if I can actually minimize this. Yeah, okay, perfect. So on my screen, I minimized the black screen, which is the output screen, because it's not going to show anything there. But if you notice on the Visual Studio actual code section, it's giving me an error. And that error actually says exception thrown, name my tuple, which is my variable, is not defined. And the reason it's not defined is because I deleted the entire variable and everything that exists inside of that variable. So it's gone. It's completely gone. I can create my tuple again and assign it something else completely. But it would be a brand new variable in that case. So I just wanted to show you guys that, that you could just delete a tuple. And that's pretty much the only way you can kind of fix mistakes when you're creating a tuple. So yeah, that's it. I've got nothing else for you guys. So this week it was a lot of method use, a lot of learning what a tuple is, learning more of how to use lists, and that's pretty much it for this chapter. It's a lot easier than last week. So in my opinion, functions are probably one of the most important topics when it comes to learning Python. And then obviously object-oriented programming, which we're going to get to in a later week. So in my opinion, it's like object-oriented programming, functions, loops, and then conditional statements. And then lists and tuples are important, so don't think they're not important. But in my opinion, they're just easier to understand because it's very straightforward how to use a method and then how to use a built-in function. So you saw both being used in this video. So I would just say practice using the method, using the built-in function, whether it's in your homework, whether it's just in Visual Studio, just write some code, find some code online, There's tons of resources online that you can use. If you guys want specific resources beyond just the coding packet that I give you guys can reach out. And I have tons of websites that I can point you guys to if you guys want further practice. Um, so yeah, that's pretty much it. That's all I've got for you guys. So 55-minute video, I think that's really good time, at least considering where we started from, which was like an hour and a half videos. So that's it for me. I'll see you guys in week 6. All right, I'll see you guys.